In this video, we're going to look at a reduction formula for an integral of powers of secant. So we're being asked to show that we can rewrite the integral of secant to the nth power x dx in terms of the integral of secant to the n minus 2 power of x dx. So that's what we mean by a reduction formula. We've made this power on secant go down by 2. Okay, so say we had integral of secant to the 6th, we can write that in terms of integral of secant to the 4th, and then we can do secant to the 4th in terms of integral of secant squared. Once we get to integral of secant squared, we know that's tangent. So this reduction formula allows you to take higher powers of secant and integrate them by in terms of the lower integrals of lower powers of secant. So in this case, we're asked to show that the integral of secant to the nx dx is equal to secant to the n minus 2x times tangent x over n minus 1 plus n minus 2 over n minus 1 integral of secant to the n minus 2x dx. Of course, we don't want n equal to 1 because the formula can't possibly work, because if we put 1 in, we get a 0 in the denominator in both of those constants. All right, so the trick here is to rewrite our secant to the n as secant squared, because I know an antiderivative for that, and then left over it would be secant to the n minus 2. So since I know an antiderivative for secant squared, I'm going to let that be my dv. That means the secant to the n minus 2, x must be our u. Anti-differentiate secant squared x, we get tangent x, and antiderivative is tangent. Over here, I got to take a derivative. We need to use a chain rule. Outside function's n minus 2, so we bring down the power, decrease it by 1. Inside function is secant x. Its derivative is secant x tangent x. All right, apply our integration by parts formula. U times v is secant to the n minus 2 x times tangent x. V du has a constant of n minus 2 out in front. Pull it out in front. We're left with secant to the n minus 2 tangent squared x dx, and the tangent squared comes from the fact that we've got a tangent x in du and a tangent x in v. We're going to rewrite everything in terms of secant. Remember, trig identity here, tangent squared is the same thing as secant squared minus 1, so we'll replace tangent squared with that. Now we can take the secant to the n minus 2x, distribute it over both terms, and break the integral up at the minus sign. So here we've got integral of secant to the nx dx minus integral of secant to the n minus 2x dx. This is still this is subject to being multiplied by this minus n to the minus 2. So if we distribute that through, we get a minus n minus 2 times integral of secant to the nx dx, and then minus and minus makes a plus n minus 2 times integral of secant to the n minus 2x dx. I have integral of secant to the n x dx over on the left-hand side. So we'll add that over. We have one of them over here. We'll add an extra n minus 2. So that gives us n minus 1 integral of secant to the nx dx. And the other pieces didn't change. And then finally, to solve for your integral of secant to the nx dx, we can divide by n minus 1. And get finally, for our reduction formula, secant to the n minus 2x tangent x over n minus 1 plus n minus 2 over n minus 1 integral of secant to the n minus 2x dx. And that's it, as long as n is not equal to 1.